Today we're going to be looking at the optimum area and perimeter of a rectangle. So prior to today you should have tackled these two investigations on the screen, and you will notice something about what characteristics have to be present for an optimum perimeter and area of a rectangle. So after the completion of the investigations, you should have found out that a square is considered the optimum or best rectangle because it first maximizes the area within a given perimeter and it minimizes the perimeter within a given area. And the two formulas are located below. So the optimum area and perimeter formulas are as follows. Area is equal to a side length squared, and perimeter is equal to 4 times the side lengths. And again, those two formulas will give you the best or optimal rectangle. Let's now look at some examples. So example 1, determine the maximum area of a rectangle with the perimeter of 40 meters. So we're going to use the formulas for above, as they again are the formulas for optimal rectangles. So first, since we're given the value of the perimeter, let's start by using the perimeter formula to find our side length, and then use that side length to find the area. So we know that our formula for optimal perimeter is P is equal to 4 times the side length. Now let's plug in our 40 meters for the perimeter and solve for S. So let's divide both sides by 4. And again, these cancel out, and we're left with 10 equals S. So now that we know our side length, we can calculate the maximum area. So from above, area is equal to the side length squared. So area is equal to 10 squared, just inputting this value here. And finally, area is equal to 100 meters squared. So therefore, the maximum area of a rectangle with the perimeter of 40 meters is 100 meters squared. Taking a look at example 2, it states determine the minimum perimeter of a rectangle with the area of 121 centimeters squared. So we'll use the same approach as before. So we'll use this area in the area formula to find our value for S, the side length, and then we'll plug that value for the side length into the perimeter formula to come up with the perimeter. So area is equal to the side length squared. We know our area is 121 centimeters squared, so let's plug that in and solve for S. So now we just take the square root of both sides, and these will cancel out, and we're left with the square root of 121 equals S, and therefore we have 11 centimeters equals the side length. So now let's plug that side length into the optimal perimeter formula. So perimeter is equal to 4S, plug in 11 for S, and we get the optimal perimeter is equal to 44 centimeters. So the minimum perimeter of a rectangle with the area of 121 centimeters squared is 44 centimeters. Our final example is an application question. Farmer Fred is a cattle farmer, and he wants to build a new pen to keep his cows together. He has 100 cows, and each cow requires 4 meters squared of grazing space. If fencing costs $15 per meter, what is the cheapest pen Farmer Fred can build to contain his cows? So first let's figure out how much grazing space he needs for all his cows. He needs 4 meters squared for each cow. There's 100 cows, so multiply it by 100. So the total area of this grazing space that we're creating needs to be 400 meters squared. So if we're paying for this fence, it makes sense to create an optimal rectangle, because then we get the maximum amount of area for the minimal amount of perimeter, which is the minimal amount of fencing costs that we're going to have to buy. So we'll use our formulas above. Since we have our value of our area, let's use the area formula to solve for the value of S. So let's plug in our 400 meters squared and solve for S. Take the square root of both sides. These guys cancel out. We're left with the square root of 400 is equal to S. So 20 meters is the value of S. Now, let's plug that into the perimeter formula to figure out how much fencing we need. 4 times 20 meters. Therefore, we need 80 meters of fencing. And finally, to figure out the cost, we know that the cost of fencing is $15 a meter, so we'll just do 15 times 80 meters, which is equal to $1,200. Therefore, the cheapest pen Farmer Fred can build to contain his cows is a pen that costs $1,200. And we know that it's the cheapest and most efficient because we used our optimal area and perimeter equations, which we solved for above.